radioactivity, we can predict the half-life by the initial amount times e raised to the negative kt. That's how the decay occurs. But when we say half-life, what we're really saying is it's 1/2 of what the initial was. Okay, and so usually what we do is we can solve for K or T. So that's the model that we use, and it says find the half-life of a radioactive substance. Oh, I kind of skipped right to the answer. Where this is derived from is the growth model, which is the amount that you left with is equal to the initial amount, and it grows, or in this case decays, continuously. All right? So if I take a radioactive isotope, it has a rate in which it decays, and it doesn't do it quarterly or daily or once a second. It does it continuously. So we take that continuous model, and since it decays, that means it gets smaller as time increases. We have this little negative sign here. So now if I move that around, what I'm really saying is I want to end up with 1/2 of what I originally started. So 1/2 of what I originally started, this becomes 1/2 y naught is equal to y naught e to the negative kt. Okay, and if I, so that's where this comes from. Okay, so it wants me to figure it out. It says find the half-life of radioactive substance with the decay equation, starting off with our growth or decay model, and then show that the half-life only depends on K, the rate in which it changes or grows. So what I would do is if I take this whole thing and divide by y naught, these cancel, and I get e to the negative kt is equal to 1/2. Okay? I don't like the kt. In other words, I got to solve for k, and I can't do it when the k is raised to a power of e. So what I'm going to do is I'm going to take the natural log of that, and remember whatever I do on the other side, I got to, whatever I do on one side of the equation, I got to do on the other. The natural log and e are inverse operations of one another, so they kind of undo each other. So on this side, I get negative kt is equal to the natural log of 1/2. Okay. Now, I said, I think I worded it wrong. I was thinking the right thing. To find that it's the time that it takes to calculate the half-life of something with regards to t as time, it's only dependent upon k, because if I get t by itself, that's where I misspoke, and it was just a slip of the tongue. Oops. Why isn't that going down? Oh, I've got to extend it. If I divide both sides by k, then what I have is t is actually equal to the natural log of 1/2, which is really just a number, divided by negative k.